Hi everyone. I'm going to be showing you a couple of different ways to simplify radicals, and this should be a review from previous courses, so Algebra 1 and Geometry. You should have done this in both classes. So there are two different ways to simplify radicals. The first is using simplest radical form, meaning breaking your radicals apart into perfect squares, and then the second way is using a factor tree. So for each one of these examples, I'm going to show you both ways. It does not matter which way you choose to do these problems, you're still going to end up with the same answer. So the first way is to break these apart into perfect squares. So if you're comfortable with your math facts or your multiplication facts and you know what this number is divisible by, what we're looking for are perfect square factors. So meaning perfect squares are like 1, because that's 1 times 1. 4, because that's 2 times 2, 9, because that's 3 times 3, 16, 25, 36, 49. All of those are perfect squares. So if any of these numbers are evenly divisible by these numbers, we want to rewrite them in or as a product of two values. So if I look at the number of 18, I know that I can evenly divide that by a perfect square of 9. So what I'm going to do is I'm going to rewrite this as the square root of 9 times the square root of 2, because there's a property that says that when we have two radicals that are being multiplied together, when you multiply them, it just becomes a big radical with a number underneath. And then the reason that this way is helpful is because then you know that you can take the square root of 9, and that's a integer. So the square root of 9 would be 3, and then I can just bring the root 2 down. So the simplest radical form of the square root of 18 would be 3 times the square root of 2. So that's if you're comfortable kind of working with these values here and you know what things are divisible by and you kind of can see what the largest perfect square would be that you would want to divide by. The other way would be to use a factor tree. And a factor tree is really breaking the number underneath the root down into its smallest parts. So what I'm going to do is I'm going to say 18 is divisible by 2. So I'm going to write this as the product of 2 times 9. But I still know that 9 can be broken apart into two smaller numbers that are multiplied together. So I'm going to pull the 2 down here and break this apart into a 3 times 3. So once these numbers are as small as they can get, meaning I can't divide them by anything else other than themselves in 1, I'm going to use these numbers to rewrite the square root of 18. So this is saying the square root of 18 would be equivalent to the square root of 2 times the square root of 3 times the square root of 3. Again, using that similar property that says that when we break a number underneath the square root down into smaller pieces, I just keep those numbers underneath the root, and if I were to multiply them back together, I would get the square root of 18. And the reason that this way is helpful to kind of break down your factors into smaller pieces is we can actually take these and pair them up. So if I pair up my numbers that are the same underneath the root, the square root of 3 times the square root of 3 is actually just 3. So I'm going to bring down the square root of 2, because what ends up happening here, the square root of 3 times the square root of 3 is actually the square root of 9, which is just 3. So the square root of 3 times the square root of 3 is just 3. And look, this is exactly the same thing that we have written over here, just in backwards form. Generally, in simplest form, we would write the number in front of the radical. So this ends up being 3 root 2. So we'll do a couple more examples. I'll show you both ways to do this, again, using the perfect squares or using the factor tree. So our next example is the square root of 75. So if I think about the largest perfect square that I can divide 75 by, I know that's divisible by 25. So I'm going to write this as the square root of 25, and 75 divided by 25 is 3. So multiply that by the square root of 3. And again, the square root of 25, I can take the square root of that, and that would be 5, and bring down the square root of 3. So simplest radical form for this one would be 5 times the square root of 3, or 5 root 3. Instead, if I wanted to use a factor tree, again, I can kind of start breaking 75 down into smaller pieces. So if I were to, I know that 75 is at least divisible by 5. So if I do this like 5 times 15, bring down the 5, I can break down the 15 into some smaller pieces here. So 5 times 3. And again, these are small numbers. They can't be divisible by anything else other than themselves in 1. So I'm going to rewrite this as the square root of 75 is equal to the square root of 5 times the square root of 5 times the square root of 3. Again, just taking these numbers and kind of bringing them underneath the roots here. And again, here's a pair of square roots. When I multiply the square root of 5 times the square root of 5, that just gives me 5. And then I'm just going to bring down that extra root at the end. So that means that my simplest radical form here would be 5 root 3. And again, that's exactly the same thing that we got using that other method. So a couple more examples. So the square root of 12, if I think about the largest perfect square that 12 is divisible by, that would be 4. So I'm going to break this down into the square root of 4 times the square root of 3, because 4 times 3 gives me 12. And then the square root of 4 is just 2. And I'm going to bring that square root of 3 down. So simplest radical form here would be 2 times the square root of 3. If I use the factor tree, I know that 12 is divisible by 6, so I can write that as 2 times 6. I can still break 6 down, so I'll pull down that 2. 6 I can write as 2 times 3. And here's my smallest number, so I'm going to rewrite this as the square root of 12 is equal to the square root of 2 times the square root of 2 times the square root of 3. Here's a pair of square roots here. Square root of 2 times the square root of 2 is just 2. And I can bring down that extra square root of 3 on the outside. So 2 times the square root of 3, which is exactly the same thing that we got over here. All right, a couple more examples. So square root of 48. The largest perfect square that 48 is divisible by is actually 16. So I'm going to write this as the square root of 16 times the square root of 3. I know that 16, I can take the square root of that to get a nice integer number. So that's going to give me a 4. And I can pull down the square root of 3. So 4 times the square root of 3 is my simplest radical form. If I use my factor tree, I know that's going to be 2 times 24. I can break down my 24 a little bit more. So 2 times 12. I can still break this down. So I'll just pull down these 2's on the outside. I can write that as 2 times 6. And I can still work with a 6 on the outside. So pull down those other 2's. And I can write that as 2 times 3. So now I have a lot of factors to work with here. So when I write this out, I'm going to write this as the square root of 48 is equal to square root of 2 times the 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 square root of 3. And here, we're going to actually have multiple pairs. So I have one pair of the square root of 2's, but I also have another pair of square roots of 2's. So this is going to turn into the first pair of square roots of 2's being multiplied together is going to be 2. Multiply that by the second pair of square roots of 2 being multiplied together is going to give me another 2. And then I can pull down that square root of 3 on the outside and then just clean this up by multiplying those together. It's going to give me 4 times the square root of 3. Which is exactly the same as what I got over here. Okay, and my last example, 98, some of these numbers are getting a little bit larger. So again, if you're comfortable with your kind of multiplication facts and you know what the perfect square is that goes into 98, this might be the way to go on this side. But again, I'll show you guys using the factor tree. The largest perfect square that divides 98 evenly is actually 49. And that's when I divide 98 by 2. So there's a large perfect square that goes into this one. So if I take the square root of 49, that's going to give me 7. And pulling that square root of 2 down is going to give me 7 times the square root of 2 as my simplest radical form. If I want to go my factor tree way, well, if I divide 98 by 2, that's going to give me 49. And I know that I can break down 49 into 7 times 7. And these are actually going to be the smallest numbers that I can get in my factor tree because I can't divide any of them other than by numbers other than themselves or 1. So I'm going to write this as the square root of 98 is equal to the square root of 2 times the square root of 7 times the square root of 7. I have a pair of 7's here. So I'm going to pull down the square root of 2, and square root of 7 times the square root of 7 is just 7. So here I have the square root of 2 times 7, but again, I'm going to write that a little bit nicer and make that into 7 times the square root of 2, which again is exactly the same as what I got over here. So I'm going to have you guys try some examples on your own on the following page where it says you try, and we will talk about them in class on Monday.